Good afternoon. For this talk, I would like to discuss PubSub, MQTT, and JSON, and how it can be used as a platform for rapid development of applications with OPC UA. So it's worth talking a bit about PubSub and what it is and how it relates to client server. Client server is designed for tightly coupled applications where there's a need to browse the address space to discover data and events that are available. Each client has its own specific needs in terms of what data and events it's interested in and sets up its own subscriptions. These subscriptions can change often based on the changing needs of the client. And there may be a need to call a number of methods in sort of a tightly coupled fashion where you're doing some more complex orchestrations. All of these are characteristics of systems that are benefit from the one-to-one connection that you get from client server. PubSub is designed primarily for loosely coupled applications where there's no real need to browse the address space. Clients can share the same subscription. The same data can be published and many clients can use it, and there's no real reason to change these subscriptions once they're set up. There's a limited need for methods in terms of uh, communicating back from the subscriber back to the publisher, although there could be some actions. You're not going to get complicated orchestration steps. So if you have an application that sort of can work with the model of the PubSub model in terms of loosely coupled applications, and this actually works for a lot of MES and ERP and cloud connectivity. This is the model that makes sense. So yeah, you will find that PubSub will be a good solution for your task. Now, PubSub was designed to be an add-on to OPC UA client server. We rely on OPC UA client server to provide the APIs used to configure the publishers. And the publisher itself can be a client of a server to subscribe to the data that it then publishes. And this was all intended to try and create a cohesive ecosystem where you have your same information models and your same data that can be available via multiple mechanisms depending on your need. And so you can leverage UA in different ways depending on what is required by your application. But PubSub stands on its own. There is no need to have client server involved at all. You can have your configuration, you can have a direct connection to your industrial process, and that's all you need. If you're pushing data out, if you've got an application where all you need to do is push everything that's in your device out to the broker and the subscribers, and subscribers can consume whatever you choose to publish, then that's all you need. And this is kind of the basis for the rest of this talk in terms of how can you build very quickly, build a PubSub application that can do the basic things that you need without having to have any special libraries or any special environment. So based on the idea of saying we're only going to build PubSub, that's all we're going to do. We're not even going to look at client server. We don't need any of the complexity that comes with the tightly coupled model. Then the first thing you need to do is you need to think about the data that you need to publish. And so for this purposes of this example, I've chosen a simple power consumption meter that publishes three different points that are related to the power consumption calculation, along with the engineering units and some descriptive information that it will be relevant to consumers. So one obvious way to get this information to consumers is to choose a widely understood format like JSON and simply create an object with name value pairs that have the current values for each of the different values that I've chosen to publish. And JSON is the default format for the web or any sort of enterprise applications. They have native support for it. Any sort of JavaScript application has JSON serialization sort of as a core part of the language itself. Um, and so you create the JSON message and you send it out, and this becomes an OPC UA pub sub message. This is it. That's all you need to send. Uh, and this can be consumed by anybody who understands JSON. Now, one of the important aspects of OPC UA compliance is that you also have to support gzip. And this is an important additional requirement designed to enhance interoperability because JSON can be wordy. And in order to manage this, the option of being able to zip the data before sending it out is an extremely valuable tool for many different applications. The MQTT 5.0 content type is used to indicate whether or not a given message contains raw JSON or compressed data. If you're using MQTT 3.1 to publish, the subscriber can still check the data payload for the gzip header and assume JSON if it's not present. So you've got this very basic message format that's built entirely on well-established and well-used web-based data formats. So in addition to publishing the data, you actually have to provide some information about your current status as a publisher. And so any pub sub will have to create the status message and publish it to the well-known status topic. Now, every publisher has to have an identifier which is unique within the context of the system, which in many cases is simply the broker that you're connecting to. And this publisher ID then shows up in the topic names where it's publishing the status. The clients can use wildcards on the well-known topic name to basically receive updates from every publisher that appears in the system. The status message allows you to take advantage of the will mechanism that's built into MQTT, where if a publisher disappears, the broker will detect that the publisher is gone and will automatically send a final message on the specified topic to tell the subscribers that the publisher is now gone. And this is a very useful mechanism in a lot of contexts. It's not universally useful, which is why we also have the option of sending a status message that has an expiry time, and then the subscribers then would get periodic updates. And if they don't get an update, basically because the expiry time has elapsed and they haven't received an update, then they would assume that the publisher is now offline. So two messages. Decide what to publish, create a JSON representation, connect to the broker, send the status, then periodically send the data. You're done. You've got your basic OPC UA pub sub application that you could probably implement in 30 minutes to an hour, maybe less, depending on how much knowledge you have about the APIs used to talk to the MQT broker or serialized data using JSON. But what's missing? Well, in this model, this sort of very dead simple model, we're sort of assuming that the data messages themselves have a certain level of self-describing, so the consumers can infer enough schema information from the names of the JSON objects that are sent, the names of the fields in the JSON objects, and there's no need for additional information like engineering units. This is generally not realistic. We need to have some sort of metadata, and we'll talk a bit about how to add metadata to this scenario in the next slides. But there's also no ability to discover what data is being published. So you can discover that a publisher is there. You can subscribe to whatever places where the data is being sent, and you can get the data messages, but you can't know in advance where the data is going to appear. So the need for discovery is important in any sort of real system. So let's talk about adding the metadata. Now, with OPC UA PubSub, important design decision is that the metadata is sent in a separate channel from the data. So you don't mix the metadata with the data. So what it means is that your actual data is as small as possible. And if you're using delta frames, the data itself, each message will only contain the values that have changed from the previous message. So you can get down to very, very small messages that are being sent out each time you are reporting changes to the system. Separate from that, you have the relatively rarely changing metadata that's going out to a different topic. And there needs to be a way to link the data messages back to the associated metadata. And this is why we've added in an additional header here with additional information that is useful. So specifically the publisher ID, the dataset writer ID, and the metadata version. And the metadata version allows the metadata to change over time and allows the subscriber to know if it just got a data message that's using a metadata version that's different than the one that it currently has cached. So the metadata, the default topic for the metadata is based on the writer group name and the dataset writer name, which can actually be put in the messages, but that's not necessary if you're using the discovery mechanisms that I'll be introducing later on in this talk. But just in general, there is a way to link directly from the data message you get to a specific topic that you can subscribe to and then get the metadata that you need. So the metadata itself consists of a structure with a list of fields. And for each field, you have a name and a data type, as well as a number of properties. Um, and these properties are tied into the OPC UA ecosystem. These are things which are defined by OPC UA information models and allow you to standardize information across many different types of devices. So engineering units is standard, EU range is standard. We've got standard properties to represent labels that are attached to numeric values, labels that are attached to Boolean values, and so these kinds of properties can be attached to any individual field to provide important context that is needed to properly interpret the data that's in the messages that's getting sent out. Now, these things, like with all things related to OPC UA information models, vendors can define their own information models with their own properties. You could have companion specifications that could define their own additional properties that are relevant for the data that's being published. Now, the values of individual fields, they can be simple types like strings and doubles, but they can also be complex types, so structured values. So the schema for the structured values is also included in the metadata. So basically everything that you need to understand the contents of the message is in the metadata. Now, the metadata message itself, as I said, it will be larger because of the amount of information you're trying to be putting in there, but it is sent rarely. And it's sent to a topic with the retain flag equal true, so any subscriber can come online and be able to get the metadata before it gets any data and be able to use that to interpret the data messages that it's received. Another optimization that's available is you can actually share metadata across multiple publishers. So if you have a factory where you've got 50 of those power consumption meters distributed at different places and they're all publishing the same data, the same messages. You can have a single process, a single publisher that's publishing the metadata that gets reused by everybody. And so you don't need to be sending this information out multiple times for every individual instance. You could send it to one topic that everybody's using to report their metadata. And the message format has ways to link these things back, link individual data message back to a specific shared metadata. Now, the metadata itself, if you're not using shared metadata, can also be a file on device that can be just sort of read off flash and sent out. So it's very efficient to produce and publish these metadata packages if you have a small low power device that needs to simply report a small number of data points. So with the metadata, you are now able to completely understand the information that's coming in the data messages. But you still don't have any information about what exactly publishers are going to publish. And this is where the connection messages come in. So the connection messages basically tells the subscriber everything that a particular publisher is going to publish. So basically, a publisher will usually publish multiple data sets. And these data sets can be grouped, related data sets can be grouped together into things we call writer groups. And this grouping is conveyed in the connection message. The connection message also allows publishers to use non-standard topic names for data and metadata. And this is a key feature needed to support any sort of integration with an UNS system where you want to be able to uh, build up your topic tree based on some sort of ISA 95 description of your factory. You don't want to be tied into some rigid three-level hierarchy, which all of the standard topic names follow in OPC UA Pub Sub. But and the connection message allows you to communicate where to go get the data. The connection message itself is always sent to a standard topic. So you always know where to go get the connection message. And from there, it tells you where to go get the data and where to go get the metadata. And getting the metadata could be coming, as I mentioned before, it could be coming from a shared source. So you don't have to send the same metadata out many times for hundreds of identical devices. And there's other parameters that specify things like quality of service, publishing interval, and the keyframe count. Just a brief discussion of the keyframe count. When you have a pub sub system, you want to be able to send out you want to be able to optimize the amount of data that gets sent out with each message. So each message that gets sent out is typically only going to be the changes from the previous message. But if you have a new subscriber that comes on and they get that data message, they don't have the initial state. They don't have any the reference point for all the data. So in OPC UA, we solve that with a keyframe. So periodically, you would send a keyframe that would have all the data, and then that would reset the baseline, and then after that, you would have a number of data delta frames. So that the frequency of the keyframes is one of the things that will show up in the connection message. So a more graphical display of how these groups and the writers and the metadata all fit together into the messages. The network message itself, in the previous examples where I showed you a couple JSON messages, that is the simple case where you have one data set in a single network message. And that is a very common use case, and we'll see that a lot. But OPC, in the more general case, publishers can sort of say, well, I've got all of these related data sets that I would like to be able to bundle together into a single network message, because it's either relevant from an information model perspective, or I'm trying to optimize the number of messages that I want to send out. There's lots of reasons why you would want to do this bundling, and you would specify how things are bundled with this writer group dataset writer structure. The dataset writers are identified by a number that's unique within the publisher. Writer groups are identified by names that are unique within the publisher, and the writers also have names that are unique within the group. And these can be used to build up the standard topic names that can be used to find different information about the individual writers that are like the metadata, for example, that's getting published. Now, all of what I have discussed in this talk is available in real code on GitHub with the IoT Starter Kit. It includes a fully functional publisher and subscribers, but it also has a number of quick starts that start with the basic application with 100 to 50 to 100 lines of code allow you to implement a publisher and a subscriber. An important thing, no custom UA specific libraries required. All the code that you need other than the MQTT and the JSON serialization is available for you to look at and for you to review and for you to play around with. This IoT Starter Kit is a great way for anybody looking for an easy way to get into the world of OPC UA Pub Sub and to get some real applications up and running really fast. The current one doesn't include actions. We're about to release the actions in the newest version of the spec, but the actions are currently prototyped in the member-only version of this repository if you are an OPC Foundation member and you have access to that. I'd like to thank you all for taking the time to listen to this presentation. I hope you found it useful. I'll be answering any questions that you might have that in the chat feed that it comes along with the event. Have a very good day.